Hi everyone. In this video I am going to discuss about reflex klystron characteristics. In my previous video I have already explained microwave bench setup, and this is the microwave bench setup. So this microwave bench setup consists of klystron power supply, klystron tube, cooling fan, isolator, variable attenuator, frequency meter, slotted section or slotted line, detector mount, and it is connected to the different components CRO, VSWR meter. So depending upon the experiment. And klystron power supply. So klystron power supply is a regulated power supply for operating low power klystron. So klystron power supply use of velocity modulation and current modulation. So to transform a continuous electron beam into the microwave power. Before switch on the klystron power supply, everyone should follow some instructions that are, and this is the beam knob and this is the Rippler knob. Before switch on the power supply, this beam knob is fully set in anti-clockwise direction or minimum position. Beam knob is fully set in anti-clockwise direction or minimum position. And this is the Rippler knob, and this Rippler knob fully set in clockwise position, clockwise direction or maximum position. And the meter selection, now here there are three options: voltage mode, current mode and Rippler mode. So before switch on the power supply, this is put in current position, and this modulation CW, AM, FM, EXT, and this is set in AM position, and this amplitude and frequency knobs are fully set in anti-clockwise direction. And after that set this cooling fan in front of the klystron tube. So these are the instructions everyone should follow before switch on the power supply. And after that switch on the power supply and switch on klystron power supply and switch on HT mode and wait some time. Electrons are flowing slowly and current increases slowly. So wait some time, and after that we will increase the beam current. So now here the current is constant 12 milliampere. So now vary the beam knob. Vary this beam knob in clockwise direction slowly. Set the beam current 15 milliamperes. And another important point is, after switch on the klystron power supply, beam current don't cross 16 milliamperes or 15 milliamperes. And after that note down the beam current 15 milliamperes. So beam current is 15 milliamperes. And after that note down the beam voltage. This is put in voltage position, and the beam voltage is 216 volts. Beam voltage is 216 volts. And after that this is put in regular position and observe the square wave in CRO. And vary this Rippler knob in anti-clockwise direction slowly. Observe the square wave in CRO and little bit increase this amplitude. And vary the Rippler knob in anti-clockwise direction slowly. Observe the maximum square wave in CRO. And that is the maximum square wave. And after that measuring the square wave, observing the square wave, observe the reflex klystron modes. And this is mode 1, mode 2, mode 3, like that. So note on the tabular column: mode 1 Rippler voltages, mode 2 Rippler voltages, mode 3 Rippler voltages. In mode 1 note down the dip frequency values and output voltages in CRO. So first So before observing the mode, this modulation, when you observe in the Klystron modes, this modulation is put in FM position, and these frequency knobs are fully set in anti-clockwise direction or maximum position. So the modes will be observed on the CRO. And after that, vary the Rippler knob in anti-clockwise direction slowly. Vary the Rippler knob in anti-clockwise direction slowly. Observe the left minimum mode, middle mode, and right minimum mode. And at the same time, note down the left minimum in mode 1. Note down the left starting mode of the Rippler voltage, middle of the Rippler voltage, and right of the Rippler voltage. And vary this Rippler knob in anti-clockwise direction slowly. And the mode is started, and that is a starting position. And this is a starting position of the mode. So at that point, note down the Rippler voltage, and the Rippler voltage is 256, and that is the left minimum. In the same direction, vary the Rippler knob slowly. Observe the middle one, and this is the middle one. And this is the middle one, and at that point note down the Rippler voltage, and the Rippler voltage is 250 volts. And next vary the Rippler knob in the same direction. Observe the right minimum, and that is right minimum. At that point, the Rippler voltage is 240. In the same direction, vary the Rippler knob. And the next mode is started, and that is the starting mode 2. Starting value. Okay. And leave it the first one, and start the next one. Leave the first modes, first left Rippler minimum, and middle Rippler voltage, and right Rippler voltage. And after that we will note down the next mode is starting voltage is 221 volts. Now here 221. The mode starting point left minimum is 221, and vary the Rippler knob in the same direction. Observe the middle. At that point, the Rippler voltage is 212, and next vary the Rippler knob in the same direction, anti-clockwise direction, and that mode is ended. And at that point, the Rippler voltage is 172 volts. And now vary the frequency meter slowly. Observe the dip frequency in CRO. Observe the dip frequency, and note down the dip frequency value in frequency meter, and note down the output value in CRO. Left dip frequency, middle dip frequency, and right dip frequency. So vary the frequency meter, slowly observe the dip, that is the dip, and observe the left dip frequency, that is the starting of the left dip, and at that point, at that left dip, note down the dip frequency value in frequency meter. So now here, and this is a straight line, and between these two, and this is 10.45 and this is 10.05. What is this one? 10.5,
10.05, 10.06,
10.6. So 10.45 and this is 10.6, approximately 10.6. The dip frequency is approximately 10.6 gigahertz, approximately 10.6 gigahertz. So in the same direction, vary the frequency meter, observe middle dip, and first note down the output voltage in CRO in the left dip frequency, that is the left dip frequency. In that left dip frequency, observe the output voltage in CRO. So this is in approximately 1.6 and 1.6 into 0.2. 1.6 into 0.2, the output voltage in CRO at the left dip frequency. Next, observe the middle dip frequency. Observe the frequency meter in the same direction and observe the middle dip in CRO. So, and the middle dip at that middle dip, note down the output voltage in CRO. So this is approximately 1, 2, 3, 3.4 boxes or 3.5 approximately. So 3.5 into 0.2. 3.5 into 0.2. And at that point, note down the dip frequency, and this is 10.45 and this is 10.45 and this is 10.6. So this is between approximately 10.5 gigahertz. Approximately 10.5 gigahertz. And next, vary the frequency meter in the same direction. Observe the right dip frequency. At that dip point, note down the frequency value in frequency meter and note down the output value in CRO. So now here the dip is that is approximately 1.6 into 0.2. 1.6 into 0.2. At that point, the right dip frequency is, and this is 10.45. So 1 division is equal to 0.005. 1 division is equal to 0.005. And after 10.5, there are 2 divisions are there. 2 into 0.005. So 2 into 0.005 is 0.01. So 10.45 plus 0.01, 10.46 and 10.46 gigahertz or approximately 10.4 gigahertz. So now here the trading is little bit mistake in frequency meter, frequency value. So this is left dip started and the starting mode left dip started. At that point the frequency is, this is approximately 10.5 gigahertz, not 10.6. So previously note down here 10.6 and that is approximately 10.5 gigahertz, and that is the left dip and the middle dip, and this is the middle dip and the middle dip. So in the middle dip, now here the frequency value in frequency meter is 10.45 and this is the 10.5. So between 5.45, so one division is equal to 0.005. Now here the approximately 5 divisions are there. 5 into 5 divisions into 0.005, approximately this one is 10.475. 10.475, and vary the dip frequency meter in the same direction. Observe the right dip frequency. At that point, the frequency value in frequency meter is approximately 10.45 gigahertz. So previously noted down 10.6, 10.5, 10.4. Now we are the in mode 1, the left dip frequency value is 10.5 gigahertz and middle dip frequency value is 10.47 gigahertz, and third one is 10.45. And this is the mode 1, Rippler voltages, output voltage in CRO and dip frequencies. And similarly, observe the mode 2, mode 3, and note down the mode 2 Rippler voltages, and calculate the output voltages in CRO, and this dip frequency is same in mode 2. And similarly, note down the mode 3 Rippler voltages and observe or note down the output voltages in CRO, and this dip frequencies are same as in mode 1. So now vary this Rippler knob in anti-clockwise direction slowly. Observe and the second mode, left minimum. And that is the starting point. At that point, the Rippler voltage is 167 volts. And vary the Rippler knob in the same direction. Observe the middle. Now start the mode is started. Now this is the starting. Mode is started. That is the left minimum. At that point, the Rippler voltage is 159. So vary the Rippler knob in the same direction. Observe the middle one. That is the middle one. This is middle one. At that middle one, the Rippler voltage is 154. And now vary the Rippler voltage in the same direction and observe right ending mode. That is the right ending mode. So that mode is ended. At that point, the Rippler voltage is 143. And now vary the frequency meter slowly. Observe the output voltage in CRO, left minimum output voltage and middle value output voltage and right minimum output voltage. So vary the frequency meter slowly. Observe the modes. That is the mode is starting. Dip is started. That is the left minimum dip. And this is approximately 1.6. Starting is 1.6 into 0.2. So 1.6 into 0.2 volts. And vary the frequency meter slowly in the same direction. Observe the middle dip. In that middle dip, note down the dip frequency value in frequency meter, and this is approximately 1 box, 2 box, 3 point is approximately 3.4 into 0.2. And vary the frequency meter in the same direction. Observe the right dip, that is the dip ending position. At that position, note down the output voltage in CRO, and this is approximately 1.6 into 0.2. So now here we observe that mode 1 and mode 2, and left minimum and right minimum, mode 1 and mode 2 same, and only the middle value is changed. In the mode 1, the middle value is 3.5 into 0.2. Here the middle value is in mode 2 3.42 into 0.2. Next, note down the mode 3 Rippler voltages and corresponding output voltages in CRO. And vary the Rippler knob in the same direction, that is anti-clockwise direction, and observe the third mode left minimum. And that is third mode left minimum is started. At that point, the Rippler voltage is 117. And vary the Rippler knob in the same direction. Observe the middle one, and that is the middle one. Okay, at that middle one, the Rippler voltage is 110 volts. And vary the Rippler knob in the same direction. Observe the right ended mode, so that is mode is ended. Here in this waveform, mode is ended. At that point, the Rippler voltage is 103 volts. So now vary the frequency meter. Observe the left dip frequency, and that is the left dip frequency, and this is approximately 1.6 into 0.2. And vary the frequency meter in the same direction. Observe the middle dip, and this is the middle dip. At that middle dip, note down the output value in CRO, and this is approximately 1, 2, 3 boxes, approximately 3 boxes, 3 into 0.2. So 3 into 0.2. And vary the frequency meter in the same direction, and observe the right dip, so that is ended. So now here approximately that is 0.6 into 0.2, sorry, not 0.6, 1.6. So 1.6 into 0.2. And this is the Rippler voltages. So that Rippler voltages are observed in Klystron power supply, and these are the output voltages. So now here for all the modes we can observe that mode 1, mode 2, mode 3, we can observe that left minimum and right minimum for all the modes same, and only the difference is mode 1, mode 2, mode 3, the difference is middle value. And the starting mode 1, the middle value is 3.5 into 0.2, and the second mode, the middle value is 3.4 into 0.2, and the third mode, the middle value is 3 into 0.2. Okay, and dip frequency is almost same in mode 2, mode 3 is also same. And after that, calculate the power using this expression. Power is equal to I into V0. And for all the modes, and current is almost same, that is 15 milliamperes. 15 milliamperes. So this current into this output voltage is equal to power. Calculate this power values. So now here at the same time we can observe same modes, all the three modes in CRO. So now here we can observe that. So this is mode 1 and this is mode 2 and this is mode 3. Mode 1, mode 1, mode 2 and mode 3.